Okay, good morning class. Today I'm going on to trig ratios, and that is your chapter 6, page 189. Turn to your chapter 6, page 189. Okay, now first of all, I'm going to revise what is Pythagoras theorem first. Okay, for Pythagoras theorem, we have a right angle. The side that's opposite the right angle is called the hypo. Okay, we have hypo square equals to AB square plus BC square. I think you should know. Hypo should be alone on one side. Okay, you can write it this way, you can also write it this way. It's the same, as long as the hypo is on one side. Okay, now for a right angled triangle, we always can use Pythagoras theorem. Okay, and today we're going to introduce to you the trigonometric ratios, which is called the trig ratios. Now, what are trig ratios? I'm going to explain to you. Now, if I have this angle that is C, alright, if I have this angle that is C, this side that's opposite the right angle is still called the hypo. Okay, this side that is opposite the angle is called opposite side, and this side that is beside the angle is called the adjacent side. Okay, I repeat. The side opposite the right angle is still the hypo. The side opposite the angle is called the opposite side. And the side beside the angle is called the adjacent side. Now, we are going to introduce to you three ratios. Three trigonometric ratios. Now, these trigonometric ratios must be with reference to a certain angle. That means you must know which angle you are talking about first. Then you can talk about the sine, cosine, and tangent. Now, let me explain to you what is sine of an angle. Sine of an angle, that means let's say I take angle C. Angle C, this is the opposite, this is the adjacent. Sine of this angle is the opposite side over the hypo. Okay, opposite side over the hypo. Cosine of this angle is the adjacent side over the hypo. The adjacent side over the hypo. That means the length of the adjacent side over the length of the hypo. Tangent of angle C is opposite over adjacent. Opposite side over the adjacent side. Now, some people may find that it's difficult to memorize this, so there's a short form that we can use, and that is called the tuakaso. That means for sine, S is opposite over hypo. Opposite hypo. For cosine is C, adjacent over hypo. Adjacent over hypo. For tangent is tua, so it's TOA. Tangent is opposite over adjacent. So you use tuakaso to memorize the three trigonometric ratios. Okay, so this is how we memorize the three trigonometric ratios for a certain angle. Remember, sine, cosine, and tangent must be with reference to a certain angle. Now, let me give you another example. Okay, now suppose I have this second example here. Okay, now I want this angle A. Now, if this is angle A, this side is still the hypo. This side is opposite A, and this side is next to A, so it's called the adjacent side. Okay, now we know that sine is opposite over hypo. So sine is so. Opposite over hypo. So we take the opposite side, which is 4, over the hypo, which is 5. So the sine of angle A is actually 4 over 5. We take the length with respect to the certain sides. Okay. Now cosine of angle A is adjacent over hypo. Ka. Adjacent over hypo. So I take adjacent over hypo, 3 over 5. That's how I get 3 over 5. For tangent A, I take opposite over adjacent, tua. Okay, so opposite over adjacent is 4 over 3. So this will be the sine, cosine, and tangent of angle A. Alright, so I repeat. Sine, cosine, and tangent must be with respect to a certain angle. If not, you cannot find the sine, cosine, and tangent. Okay, it must be with respect to a certain angle. Alright, and we use the short form tuakaso to memorize what upon what. okay, to enable you to answer the questions properly and to memorize it properly. Okay, now I'm going on straight into exercise 6a. Can all of you turn to page 194? I'm going to teach you how to identify the hypo, the opposite and adjacent of a certain angle. Okay, I'm going to teach you how to identify the hypo, opposite and adjacent of a certain angle. Now, if you look at question 1, for each of the following right angled triangles, name the hypo, the side opposite angle A and the side adjacent to angle A. Now, angle A is here. Okay, now this is the hypo because it's the side opposite the right angle. Now, angle A is here, so this is the opposite side and this is beside it. So this is called the adjacent side. So the hypo is actually PQ. The opposite side is actually RP. And the adjacent side is QR. Okay, we must always look out for the angle. This is the opposite, this is the adjacent, and we will identify the sides accordingly. Okay, this is the question 1a. Now I'm moving on to 1b. Alright, I'm moving on to 1b, and this is the question here. We are also supposed to identify the same things. Okay, now let's take a look. This is again the hypo. This is opposite angle A, so this is the opposite, and this is the side beside it, so it's the adjacent. So the hypo is actually XY, the opposite is XZ, and the adjacent is YZ. Okay, so this is how we identify the opposite, the hypo, and the adjacent of a certain triangle with respect to a certain angle. Okay, that is your question 1a of exercise 6a. Now I am moving on to question number 2 so that you can know it better. Okay, let's take a look at question 2a. Alright, now there are 6 parts to it. I'm going to do 3 parts at the same time. Okay, 3 parts first, followed by another 3 parts. Okay, now you look at this. This one wants angle A. So the angle that is we are talking about is this angle. Now everybody look here. This is the hypo. This is the opposite. And this is the adjacent with respect to the angle A. Now sine A is opposite over hypo. Remember our rule here, dua, ka, so. So sine is opposite over hypo. So where is opposite? Opposite is 5. Hypo is 13. So I get this ratio, 5 over 13. Okay. Now next, cosine. Cosine is adjacent over hypo. So is 12 over 13. Adjacent over hypo, so it's 12 over 13. And tangent is opposite over adjacent, so opposite over adjacent, so it's 5 over 12. 5 over 12, opposite over adjacent. So we always use this tuakaso to help us find what is sine, cosine, tangent of an angle. Now, if you look at the next 3 parts, okay, if you look at the next 3 parts, they are talking about angle B, okay? They are no longer talking about angle A, but they are talking about angle B. So, if you are talking about angle B, this is the angle that is required, okay? This is the angle that is required. Now, this is still the hypo, this will be the opposite, and this will be the adjacent. Sine is opposite over hypo. So, okay? So, opposite over hypo. Alright, let me write this down again. Dua, ka, so. Cosine is adjacent over hypo, and tangent is opposite over adjacent. Now, we are going to find the ratio now. Now, opposite is 12. 12 over hypo is 13. This one is adjacent over hypo, so it's 5 over 13. And this is opposite over adjacent, so it's 12 over 5. We always use this tuakaso to give us the ratio here. But it must be with respect to a certain angle, so that we can identify where's the opposite and where is the hypo of the triangle as well as the adjacent of the triangle with respect to the certain angle itself. Okay, alright, now next I want you to turn back to page 193. Okay, now before that, I'm sorry, can we turn to page 195 first? 195, I have one more example to go through before I go to the other work example. Can you look at that question 3 of page 195? Can we all look at question 3 of page 195? Okay. I think I make a blunder here. Okay, I'm sorry. Can you turn back to page 194? I haven't done question B. Can you turn to page 194 and look at question B of question 2? Okay, I'm going to do that with you first. Okay, it's a bit too fast, huh? Sorry about that. So, can we look at question 2B of page 194? Now, I'm still going to write down tuakaso here. Okay, now this one is angle A, as you can see. Angle A. So, angle A is here. This is the hypo, this is the opposite, and this is the adjacent. Now, sine. Sine is opposite over hypo. So, opposite over hypo, it will be 24 over 25. Okay, 24 over 25. Cosine is adjacent over hypo, so it's 7 upon 25. And tangent is opposite over adjacent, so it's 24 upon 7. So this is how we get the sine, cosine, tangent of angle A. Alright, now I'm moving on to angle B. Now this one is slightly different because the angle is different, and therefore the opposite and the adjacent will be different. Now angle B is here. This is the right angle. So this is the hypo, this is the opposite, and this will be the adjacent. Okay, sine is opposite over hypo, so it's 7 over 25. Okay, 7 over 25. Cosine is adjacent over hypo, so it's 24 upon 25. And tangent is opposite over hypo, so it's 7 upon 24. Okay, opposite over adjacent, so it's 7 upon 24. Alright, so all of you must take note, we must follow the rule tuakaso in order to get these three ratios. Okay, that will complete your question 2B. Alright, take a look at it. If you need to pause the video anytime, please feel free to do so. Okay, now then I will go to page 195, question number 3. Question number 3. Okay, let's look at 3A first. Alright, the question says, find each of the following, for each of the following right angled triangles, write down an expression for all these in terms of x, y, and z. Now they no longer give you numbers, they give you letters instead. Okay, now can we look at angle P first? Angle P. For angle P, this is the right angle, so this is again the hypo, because hypo is always opposite the right angle. For angle P, this is the opposite. Okay, and this will be the adjacent. So the red color one is respect to angle P. I repeat, P, hypo, opposite, adjacent. So what is the ratio here? tua, ka, so again. Sine is opposite over hypo. So opposite over hypo will be y over z. Cosine is adjacent over hypo, so is x over z. And tangent is opposite over adjacent, so is y over x. So these three will give you the trig ratios with respect to angle P. Now how about angle Q? Now if I have angle Q, okay, if I have angle Q, hypo is still the same because it's opposite the right angle, but this one will be the opposite of angle Q, and this one will be the adjacent of angle Q. I'm using green so that you do not confuse yourself. Green color one is for the angle Q. Alright, we still use the same ratio. Sine opposite over hypo, so is x over z. Cosine adjacent over hypo, so is y over x. Okay, adjacent over hypo is y over z. My mistake. Y over z, adjacent over hypo. And tangent is opposite over adjacent, so is x over y. Okay, repeat. Sine Q, sine, opposite over hypo, x over z. Cosine of this, adjacent over hypo, y over z. And tangent Q, opposite over adjacent, x over y. So that's how you get the three ratios for angle Q. Okay, angle Q. Don't forget, the opposite and the adjacent must be with respect to the angle itself. Okay, this is the opposite of Q and this is the adjacent of Q. So please be careful of that. So we have already done how to identify the hypo, the adjacent and opposite with respect to a certain angle. So now we are going to learn how to key in the calculator for sine, cosine and tangent. Now, you have to make sure, look at the calculator, your brand of the calculator. Okay, I'm going on to work example 1. Now, you can find these three keys, sine, cosine and tangent, on your calculator. And you must make sure the calculator is in the degree mode. In the degree mode. That means you must see this DEG at the top of the screen of your calculator. For those using the Sharp calculator, you can see this function here, DRG. Above the dot, above the decimal point, there's this DRG. You just have to press second function until you see DEG at the top of your screen. Until you see DEG at the top of your screen. Okay, so that is how you change your calculator to the degree mode. Okay, now let me just show you over here. Can you see this DEG? Okay, on top here it must be DEG, the degree mode. Alright, you have to press your calculator until it's in the degree mode, and you press second function, this decimal point, until you see the DEG on top. That is the calculator in the degree mode. Okay, for those using the Casio calculator, you have to try with a calculator to see how it can change to the degree mode. Okay, if you cannot do that, please consult your friends. Okay, now I'm going on to work example 1 on page 193. Okay, on page 193. Okay, now class, it is very easy. Please make sure that your calculator is in the degree mode first. Then for sine 32 degrees, you just press sine 32. This answer will come out. Change it to 3 significant figure. Likewise, you do it for part B, for part C, for part D, for part E, and for part F. Okay, you should get these answers. Feel free to pause the video if you are pressing in the values and double checking the answer. Okay, so you just need to key in sine, cosine, tangent according to the expression given, and then you can get the answer straight away. So that is how they get the answer to work example 1. Alright, now after you're done with work example 1, I want you to turn to page 195 and look at question number 4. Look at question number 4. It says, use a calculator to evaluate each of the following. Leave your answers correct to 3 significant figures. Now, it's the same thing as work example 3. You just need to key in the calculator accordingly, but please ensure that your calculator is in the degree mode first before you key in, and you can get the answers in green that I've shown on the video here. Okay, alright. Now, so let me just summarize what I've done in this particular section 6.1. You must know the sine ratio, cosine ratio, and tangent ratio of an angle. Let's say the angle is theta, and we use tua, ka, so to memorize what is these ratios about. Okay, now this one means is opposite over hypo, this one means is adjacent over hypo, and this one means is opposite over adjacent. Okay, we must know this thing here, how to key in sine, cosine, tangent using the calculator by using the sine, cosine, tangent key in your calculator and making sure that your calculator is in the degree mode. Okay, all these will sum up all the necessary things that is required in section 6.1. Now, when you are viewing the video, feel free to pause at any time or replay if you do not understand at the first time. Okay, thank you class. This is section 6.1.